Welcome to Make Made Simple. Today we will be studying direction of friction force example 1. So this is a tutorial problem in which a wall is here and there is a ground here on which M1 and M2 are kept, and M2 is attached to this wall through a cable T. We have to find the friction and the force F is applied in this direction on M1. So we have to find frictional force on M1, B frictional force on M2, tension in the cable, and acceleration of mass 1. So first I'll draw the free body diagram of this, the various forces that are applied on this system. I'll draw that. So there is M1G. I'll use a different color. So this is M1G. This is M2G. And there is a normal reaction which is being applied here. That is N equals to M1G plus M2G. M1G plus M2G. So this is a normal reaction force N1. Then we have a force also will be applied here. That will be M2, N2, N2 equals M2G. Let's see if there is any other force here. No, that was all the forces. Four forces are being applied: M1, M2G, M1G, and this N1 and this N2. Four forces are being applied here. So what is the friction force on M1? Friction force on M1. That's the first question. So friction force on N1 on M1 equals friction force. There will be two friction force because this block is moving towards the right. So one friction force will be applied by the ground here, and the second friction force will be applied by the M2 mass here. So the two friction force are FR1 and FR2. F FR1 plus F FR2. That will be equal to M1G plus M2G nu 1, M1G plus M2G nu 1 plus M2G nu 2. This M2G nu 2 is due to this N2 force there. So this is our answer 1. Then B part is frictional force on M2. Frictional force on M2. This will be equal to FFR3 I'll write down here what are FF1, FR and F3. So we have FFR1 equals to here FFR1. Now this is moving in this direction, so the friction force will be in this direction. I'll just check. So the friction force will be in this direction. FFR3. So FFR3 equals M2G nu 2. So this is our part B answer. Now part C. Part C is tension in the cable. Tension equals FFR3 equals M2G nu 2. That is the tension here. Now acceleration, last part, acceleration of mass m1. So we have D part, E equals to F net by M equals F aiding minus F opposing by mass. So we have the aiding force we can see here is F. And mind you, this is acceleration of m1 and m2 is fixed because it is attached through a string to the wall. So here we have F aiding. This implies acceleration equals F minus FR, F minus F, FR1 minus FR2. So we have force F in this direction and friction force in this direction. So there is a FR, this is our FR2. By m1. So this will be equal to F minus friction force 1 we have here, friction force 1 this m1g m1g plus m2g times mu1 minus friction force 2, that would be equal to minus m2 minus m2 g Newton. So this whole divided by mass m1. So this is our answer. This is our answer D. So this is the acceleration that we have got. It is just a mathematical relation, and not values are not given. So I have not put down the values here. So that was all for today, guys. You can see the board. So that was all for today. Let's meet in next lecture. Till then, thank you. If you have liked the video, please do like the video, subscribe to my channel, and share it among your friends. Thank you.